Welcome 6th grade math teachers to another Prep Talk video. In this video, we will be discussing additive and multiplicative relationships, TEKS 6.6b and 6.6c. Our learning objective for this week is to be able to represent both additive and multiplicative situations using a variety of representations, including verbal descriptions, tables, graphs, and equations. And so part of our big task this week is being able to have students transfer between the different representations. And so we might start off by giving them a verbal description and ask them to write an equation and graph it and create a table. Or we might start off with a graph and have them produce a table and an equation and then maybe even create a verbal description off of that. And so you'll want your students to be comfortable transferring between the different representations of these additive and multiplicative situations. As we look at the standards that we'll cover in this video, you'll see that 6.6c is a fairly heavy-hitting readiness standard. It's been tested 8 times in the last 5 years. And the supporting standard, 6.6b, which has students writing an equation that represents the relationship between independent and dependent quantities from a table, that's been tested 2 times in the last 5 years. So when you count your wins for this week, you really want to look towards 6.6c, those 4 different representations that we talked about, and then we can clean up with having students writing the equation from a table. So you can kind of see that this TEK is really embedded into 6.6c. So as you're practicing 6.6c, you're also supporting the work in 6.6b. As we take a look at some of the released questions for TEK 6.6c, let's notice in this first question on the left that we are given an equation. Y is equal to 3.5x. When students see a form of the equation y is equal to kx, they need to know that the graph is always going to start at the origin. With that fact in mind, they should be able to automatically eliminate C and B because those graphs do not begin at the origin. Then from there, you could have them create a table of values to match it with the correct graph. If they were going to create a table of values, x and y, then starting off with 0, if we let x be 0, 3.5 times 0 is 0, so there's the origin point that we were talking about. If we let x be 1, 3.5 times 1 is 3.5. And if we let x be 2, then we know that y is going to be 3.5 times 2, which will be 7. Let's see if we can identify the correct graph based on those 3 points. You'll notice that letter D passes through this point right here, which is the point 3.5, 1. Well, that is backwards from what we needed. We needed 1, 3.5, and letter A is the graph that actually passes through that point, and so A would be the answer that we're looking for on that first problem. For the second problem on the right, you'll notice that all 4 of the graphs start at the origin, and that's because this verbal description is a proportional relationship. It says that the owner of a food cart sells an average of 120 frozen treats per day during the summer. So he doesn't start off having sold any, he starts off having sold none, and then each day he sells 120 frozen treats per day. And so that 120 represents the unit rate. That's going to tell me by how much the graph is going up each day. And so seeing that they all start at the origin, we just need to see which one is going up by 120 each day. And if you'll look at letter choice A, that is the one that is going up by 120 every day. There's 120, there's 240, there's 360, there is 480, and there is 600, etc. Again, having a students create a table to match with the graph will be a good idea. Now, in our Teach Piece notes for this week, this is going to have students actually creating the graph. So there will be some problems where they have to identify the correct answer from some choices, but you want to make sure that students are having to create these graphs on their own, because as we know in the STAR redesign, graphing is one of the new item types, and so this could very easily show up as a graphing style question on the new STAR test. So it's very important that you're having students create these from scratch so that they get that skill. The next two problems have students producing a graph from a verbal description where they have to find the unit rate. So it's a little different from the problem we just worked, because now students have to do the work of finding the unit rate first. On the problem on the left, we see that a bookstore, the total cost of 6 books is $45. So to find that unit rate, we're going to need to divide 45 by 6. And so doing that real quick, we're going to get 7.5. So if we bring down this 0, 6 goes into 35 times. So $7.50 is the unit rate. That is the cost for one book. And so we could say $7.50 per book. If we were going to write this as an equation, we would say y is equal to 7.5x, where x is the number of books that are bought and y is the total cost. We could also create a table, and that's what the question is asking us to do. So for the number of books bought, we want the cost to be 7.5 or $7.50 each. And if you look at letter A, if I buy one book, that's $7.50. If I buy 2 books, that's $7.50 times 2, or $15. And the table down the rest of the way checks out with that thinking. And so letter A would be the answer that we're after here. Again, having students transfer between those different representations, the table, the graph, the equation, the verbal description, etc., is very important. As we look at number 5, again, this is a verbal description where students are first going to have to find that unit rate. And so dividing 18 into 720, 18 goes into 72 4 times evenly, and then 18 will go into 0 times. And so the unit rate that we're looking for is $40 per hour of work. So our equation would be y is equal to 40x, because if we don't work any, we don't make any. And so it's not going to have any initial value. It's just going to be y is equal to 40x. And then having students create a table on their own. If we start with 0, we're going to get 0. If we plug in 1 for x, if we work 1 hour, we're going to make $40. If we work 2 hours, we're going to make 40 times $2, which will be $80. On and on and on and on. And so what students will realize is that A is the answer that best matches the table that they create, and so that's the answer that they want to choose. These two released items will have students creating a verbal description based on the given representation. In the first problem, we have the equation y is equal to 12x. If you actually go to the second part of each of these answer choices, you'll see that it's actually pretty easy to get the correct answer. In letter A, what we see is that this is 12 times y. Well, clearly here we see 12 times x, and so we know that letter A is going to be incorrect. Letter B, we see she gave the cashier y dollars and received $12 in change. Well, that represents a subtraction scenario, and this is not a subtraction, it is a multiplication, and so letter B is also not going to be correct. Letter C is a little closer. It says that this amount is 12 times x, and so if we start reading this from the beginning, Victoria has y dollars. This amount is 12 times x, which is the amount of money in dollars that Victoria's brother has. That is a good verbal description for this equation, because in order to find the amount of money that Victoria has, we would take the amount of money that Victoria's brother has and multiply it by 12 in order to find the amount of money Victoria has. And so that is a perfect description for what this equation represents. For number 27 here on the right, we're given a table. Now, what we want to notice about this table is that we see that at x is equal to 0, we have y is 6. And so we're not starting at the origin here, we're starting with an initial value of 6. And so we're looking for some verbal description that says that whoever started with 6 and then started increasing. And we can see that the increase is going to be adding 1 each time to whatever the y values represent. And so reading through these answer choices, you'll see that letter B says that Beatrice ran 1 mile the first week. Well, that's true, but it doesn't say anything in letter B about her having already run 6 miles. And so letter B cannot be correct. Letter C says that James read 0 books in 6 months and then started to read 1 book each week after that, or each month after that. That does not really fit the table either. And then Marion has 6 times the number of toy trains that Tony has. Well, that does not line up with our first ordered pair of 0, 6. Letter A is the best situation here. It says that Rachel had $6. Well, that represents our 0, 6 right here, that she just had $6 before anything happened, and then she started to save $1 each week. And so that represents the increase by 1 in the y values. And so letter A is the answer that we want for that particular question. Let's look at the 2 released items for 6.6b. This question gives students a table that shows the relationship between the number of slices of bread and the total number of calories in the bread. What students want to be able to do is identify the relationship between B and C. Now, one thing that they might do at the very beginning is say, okay, well, in order to get C from B, we could add 138. That would get us from 2 to 140. But they need to try that for all of the ordered pairs. If I try that for the second line, 4 plus 138 does not equal to 280. And so that tells me that that strategy, that rule is not correct. And so we need to try again. Something else that we could do in order to get from B to C is multiply B by 70. 2 times 70 is equal to 140. If we try that in the second ordered pair, 4 times 70 is equal to 480. And so the rule here is going to be B multiplied by 70, and that will get us the result of C. And if you look at the answer choices, what we see is that C is equal to 70B, which is the same as what we wrote right here. The major distractor in this particular problem is whenever the variables are switched. And so, like, for example, letter H, you'll want to be very careful to have students avoid that particular answer choice. This question is very similar. Notice, though, that it is a horizontal table and not a vertical table like the last problem, and so you'll want to make sure that you're giving students both of those representations so that they can get comfortable with both horizontal and vertical tables. What students might try to do here is subtract in order to get from S to R, and so they might say, okay, well, I could do 1 minus 5 over 6, and that will give me 1 over 6, which is the value of R. But if you go to the next column and try that again, 2 minus 5 over 6 does not equal to 1 over 3. And so therefore that rule is not correct, and we know that we're not going to be subtracting in this particular case. And so what we want to do is eliminate any that say subtracting 5 over 6, which would be G and H. So the next thing we would try to figure out is, okay, maybe this is a multiplicative relationship. And so if we multiply 1 times a number to get 1/6, that would be 1 times 1 over 6. Then 2 times 1 over 6 will be 2 over 6, or 1 over 3. And so we see that that is the relationship here. If we take the numbers in row S and multiply them by 1 over 6, that's going to result in the numbers in row R. And so writing that as a traditional equation, we will have R is equal to 1 over 6S, which is letter J. The most popular wrong answer is letter F, and so you'll want to make sure to steer students away from that thinking. Have them write this out so that they can actually see we are starting with S, multiplying by that constant, and then resulting in R, so equaling to R, have them write this out, and then rewrite it as a nice formal equation so that they can get the correct answer. If you have any questions about representing multiplicative and additive relationships, please feel free to reach out either to me, Ryan Castle, or to our middle school facilitator, Paris Scott, and we would be happy to answer any questions that you have about the curriculum or the content or how to teach these topics. Before you go, please fill out our survey so that we can know you watched the video using either the QR code on the left or the link that you see provided on the screen. Thanks so much for watching, and good luck to you and your students as you plan for multiplicative and additive relationships.